All right, so we're in Visual Studio Code. We went through the videos and we basically did like a print hello world type of thing. We hit F5 and enter and it ran and we saw it, ignore that for now. We saw it run and we saw it come out here. What I want to show you is debugging. Debugging is one of the most useful concepts in modern programming because it lets you step through code and inspect things you're having trouble understanding why the computer's not behaving the way you want. So let's go ahead and just make a really simple program like this. Alright, so we know what this is going to do. We can look at it and we figured out. You should return 1 plus 2. So I'm going to run it and we see 3. And hello world. So that's all like we expected. But what if we have something that we don't know what it's going to do as much and we want to understand the system a little better? We can add a breakpoint by clicking on the left side of this over here. And then now when we press F5 and enter to run, our program's going to stop at this point. And we're going to see some cool things on the left. Locals are automatically generated depending on where you are executing the program. These are variables you can access, but you can generally ignore these for now. Otherwise, you can add your own custom watches. So I've added these from before, A and B. And you can just press the plus and hit enter here. Or you can right click on any variable and somewhere in here says add to watch. But this is harder to navigate. I can't find it, so I'm just going to add it over here. I recommend doing it that way, but you know, sometimes it's faster to. There it is. I must have not selected it, but they're not filled out right now because code hasn't run to fill them out. This line's waiting to execute. So if I come up here and I press step over, it's going to do that line of code and go to the next one. And now I see that variable A is this huge number. And automatically up here, locals now has a variable A. So we're going to execute this line of code next. We see it's not in locals yet, and we see it's not defined on the watches like I've done. And I'll delete this duplicate. Again, I step over, and now it exists here with 2, and it exists up here. And again, now I'm just going to press F10 because I've hovered my mouse, and I see that I can just press F10. And now I have a C with a huge number, and now I print that, and the program's over. So that's worth knowing about. And I want to show you a little bit more about how Python code's interpreted, and how you want to like step into different functions, and what does that mean? Step in, step out. So I'll call this do A, and this is going to return a different function that I'm going to make called do B. So if I'm going to call it from here, I need to have declared it beforehand. So here's a function called do B. And this is going to just return itself, return the input just by 2. So function A is going to call do B with the same input, but do B is going to double it, return it. So this is kind of a stupid program, but it's going to show you how you can step into different code areas. And I'm going to show you how Python code is interpreted, sort of the order it gets read. So I've added a couple breakpoints. One right at the beginning, one in the middle of some functions, and then some down here. So I press F5 and enter, and I start on the first line because I added a breakpoint. Oh, I have invalid syntax. This is the other great thing about using an IDE like Visual Studio Code. You get these errors really quickly. And actually, you'll see underlines like this. There's a little squiggle, and it says, "What's the problem? Invalid syntax." I'm missing a colon, which is really nice. And then check this out: unused variable. So it knows that I tried to use these things, and then I never used them again. So you'll see if I come down here and I do like a print. Now, because I used it, it is no longer telling me this warning. So this isn't an error; it's just telling you this might not be right. And also this, I noticed as I hover, it says it's from Pylint. So as you're sort of, that's an extension of Python. It's a different thing that just does these warnings and these underlines and stuff like that. And formatting, if you press F1, you can go and format the document. F1 is sort of your do whatever you want sort of prompt. So I can also do color theme, which is really nice. You can find your own little color that suits you. which is I recommend doing just to make it more enjoyable to code. I like Monokai myself. But back to the underlining. You see how it says it's from PyLint. This is another extension that got installed. And the first time you open Python and save something, you're going to see a little pop-up in the corner that asks if you want to install that, and you're just going to want to say yes. And I probably don't have it installed for some of these other ones. So let's see if I change the interpreters. So here you see I have a pop-up, and you're going to see this too. And you just want to basically you want to always hit install when you see these pop-ups. And basically until you hit install, it's going to keep popping up. So I'm going to go ahead and do that, and it'll do this. This is all good stuff. But I use a new Python interpreter, but as long as it says Python 3 down here, you're good. Otherwise, you're going to want to click on this and go back to Python 3. So here I am. I'm debugging my code. A equals 4, and not yet because I haven't run the code. So I'm going to press F10 to step over. Now, if I step over this, is it going to break into here? It doesn't because the code's not actually being run. But what is happening is it's putting it into the locals, which means it's being declared in the space as something you can call. So we'll see this again in a second. There's no do B, or there's the do B, but there's not a do A yet. And as I step over, we see do A appear in the locals as something that now I can call. And then you see this crazy number, which is probably where it is in memory for this to be called. And you can ignore this stuff. You just know that it's here. And now, as I step over, you see these keep updating like last time. And I never called this code. So instead of printing C, we're going to call do A on C. And I can take off these breakpoints because we know what this does. So I'll step through it all again. There's A, we declare some variables. I ignore that run. Let's try again. Pressing F10 now. I press F10, I step forward 1, I declare these two variables, they show up in the locals. I do it again, A is a huge number. B now is 2, C is A plus B. And I press step over, which normally wouldn't go into here. I could press step in, and it would step into A, which I will do now. And then continue means run the program, which I'll do now also. But because I have a breakpoint ahead, it'll stop again. As long as there's a breakpoint, it'll keep stopping. So here's do B, and now I will step into this. AST equals 2, 3, 4. We see it appear in the locals. Return 2 times B. Step into that. There's nowhere to go, so it returns back to here. It's going to return the thing we just did, and now here is our final value. So basically come in here, play around with this, spend some time in here. You're going to learn a lot just from trying different stuff and from the upcoming test. One final thing, I want to show you what happens if you declare the same function twice in a row. I won't even do this. I'll set it up for you, and then you can come into Python yourself, and you can test using the debugger and printing, and you can learn for yourself what is this going to do. And one little hint, the linter, because we installed PyLint, there's a little squiggle here. It tells us it's already defined. So what's going to happen if I have the same function declared twice and I try and call it? Do this on your own and let me know what you find out.